Today we're going to learn how to find the intersection points of function graphs. Let's just start with the reciprocal function and the straight line. Y equals y over x and y equals x. And firstly, how to draw the two graphs independently? Let's start with the simple one, the straight line. So you can just go with y equals x. It passes through the origin, which with every x coordinate equals its y coordinate of every point. And for the reciprocal function, we can just roughly draw it like this. But how to find their intersection here? As you can see, they have a intersection point A here. So what conditions do A have to satisfy? Because it lies both on the curve, so it will not only satisfy the reciprocal one, but also the straight line, which means its value is the same on both of the equations, and they are a simultaneous one. And you can substitute y back in the first equation, and it will get the value of y. So x equals x over 1, and remove x to the left side, you will get x squared equals 1, so x would be 1. Well, of course, x have another value like -1 if we take the whole picture of the two functions. So you will not only have 1, but also -1. And we substitute back to get the value of y and x. So y is 1 or y is -1. So this would be the points of A and B. But remember, each x value corresponds to a y value. You cannot match x equals 1 and y equals -1 together because they don't belong each other. You can only use x equals 1 to solve again and finding the y value, and that's a really important thing. And this is a method called solving a system of equations to find intersection points. And let's take a look at another example. Suppose we have a parabola y equals x squared and a reciprocal function y equals 1 over x. How do we find their intersection points? Still, we need to draw their graph. And for parabolas, it looks like this. And that's the reason why it's called a parabola, because it really looks like one. And for the reciprocal function we did before, we just need to do it again. It's a reciprocal function. And clearly you can see they have an intersection point A here. And still, point A lies on both of the equations, so it must satisfy each other. So for y equals x squared and y equals x over 1 over x, they must share the same value, which means we could substitute either of them into another one. So I can substitute the second one into the first one. I will get 1 over x equals x squared, and I remove it to the right side. So I will get 1 equals x cubed. So x is 1. And after getting the value of x, I will substitute into either of them to get the value of y, which is 1 as well. So that's how I find the intersection between the parabolas and the reciprocal functions. So what about a parabola and a straight line? For example, y equals x squared and y equals x plus 2. Still, we need to draw their graphs. So the first one is a parabola. It goes like this. And the second one is a straight line. It goes like this. And clearly you can see they have two intersections, point A and point B. So it still goes the same. A and B lies on both of the equations, so they must satisfy each other, and they share the same value, which means we could substitute either of them into another one. So I can substitute the second one into the first one. It will be x plus 2 equals x squared, and this smells like a familiar recipe. It's a quadratic equation, right? You can solve it by either using factorizing or completing the square or quadratic formula. But anyways, after solving this equation, we will find the value of x is -1 or 2, and substitute those values back in either of the equations, we will get the value of y. y1 is 1 or y2 is 4. So these are the coordinates of A and B. So why can't we just substitute the value into either of the equation? Shouldn't it go wrong? Well, because both of the equations, they share the same value, so it's fine for you to substitute them back into any equation you want. And that's how we solve it. So consider a special case. Y equals 1 over x and y equals minus x. Do they have intersections? Do they meet each other? Well, everything can be told through the graph. You just need to graph them. And for 1 equals 1 over x reciprocal function, it looks like this. And for the second one, it's still a straight line with a slope of -1. So it should go in angles like this. It's 135 degrees of inclination. As you can see clearly, they do not meet each other. And from algebra, we can also explain this. When you try to solve the equation, remember, you try to solve, substitute the second one into the first one. So it will be minus x squared equals 1, x squared minus equals -1. So in real numbers, in the region of real numbers, they don't have solutions, which means you cannot solve them. And of course, based on the graph, they don't have any intersections. So this fit both from the graph and algebra. And let's do another one. So y equals 1 over x reciprocal function. And let me change the straight line a little bit. So it's not y equals minus x, but with a constant followed it, plus b, which means you're basically just move the straight line up or down. So under what case will they interact? And let me just draw the graph here. So we see a reciprocal function, and for the second one with the intercept of b, and the slope is -1. Let me go with this line. So I need to move the straight line up or down. So for what value of b will they have intersection? Well, let me just take, if b is 0.1, so obviously there will still be no intersection. Even though I change it probably from 0.4, it will still not have intersections. So under what situation will the value of b make them interact? This might be a special case. Well, if you do it in hand, well, maybe if you're allergic to graphs, you might find the tangent of their limitation is the value of b of their intersection. But how do we find their tangent? That is still a tough question. So here is a thought. We assume that they will interact. As you can see here, they definitely have intersections. So we guess, we assume, we confirm that they have intersections. And after that, we are trying to find their intersections. By how? By doing their simultaneous equations again. So let me just assume they have intersections. And then let me try to solve this. So it will be 1 over x equals minus x plus b. So it's 1 equals, I can remove x to the right side. So it will be 1 equals minus x squared plus bx. If I rearrange them, it will be x squared minus bx plus 1 equals 0. So if they do interact with each other, this quadratic equation will definitely have two roots, have two solutions, because they interact. If they interact, so from algebra, it must make sense. They definitely will have two solutions. And how to make these equations with two solutions? Based on our quadratic formula, it's discriminant b squared minus 4ac is definitely greater than 0. Only under this circumstance can make them have two intersections. So under what situation will they just have one? Well, this straight line is their tangent. So under this situation, their discriminant is definitely 0. Because they have two repeated roots. They only have one intersection. So their discriminant is definitely 0. But what if they do not have any intersections? That's quite simple. So its discriminant is smaller than 0. And from this way, you can see we link algebra and solving intersections with graphs together.